Here we have a displacement time graph for a moving object, and the gradient of this graph is the object's velocity. Now you can think of gradient, if you find it helpful, you can think of gradient as meaning slope. So in this first section here, you can see that the slope is not changing. It's not getting steeper, it's not getting shallower. So that means the gradient is constant, the velocity is constant. We draw a triangle to work out what that is, and so we've got it moves from here to here, so it's going to go 10 meters, it's going to move upwards 10 meters in 2 seconds. So its velocity in that section is 5 meters per second upwards. On this next section, the line is still straight, so that means constant velocity again. But this time our displacement is changing from 10 to 0. So our change in displacement this time is minus 10. We go from 10 back down to 0, and we're doing it in just the 1 second. So for this section here, should have labelled them, that's that one, this is this one, the velocity is minus 10 meters per second, which means 10 meters per second downwards. So for this section here, our displacement is still positive. So like, for example, right there, my displacement is still 5 meters above the starting position, but I'm moving downwards, so my velocity is negative. Okay, but then on this section here, we can see that it starts really steep, but then it gets shallower and shallower and shallower. And so in this section, our gradient is changing, and so our velocity is changing. So if the velocity is changing all the way along there, how could I calculate what it is at any particular time? Well, let's just say, because I think this is going to work out quite well, we're going to say at 4 seconds, what's my velocity? So I'm going to say right there, I know it's changing along here, but right at that 4 second mark, what's my velocity there? You need to do the thing with the ruler, where you roll the ruler around the curve. And when you get to the point you want, and the ruler's not touching, it's not touching anywhere else, it's not crossing anywhere else, you draw in your straight line. That is your tangent, and then you find the gradient of the tangent. And so, let's see how well this works out. About 5.5, I think that is, about 5.5 seconds. Okay, so that is what's our change in displacement? So our displacement goes from 0 down to minus 10. So our change in displacement is minus 10 meters. And the time is 3.5 seconds, which is minus 2.9 meters per second if I round to 2 sig fig. So at that moment there, the object is travelling downwards because of the minus sign at 2.9 meters per second. Unfortunately, my printer's broken now, so I've drawn out question 2, but if you download the questions from the website, the PDF, you'll get the proper exam question for this one. So the question says, below is a graph of the displacement against time for the motion of a radio-controlled model car. Use the graph to describe and explain, without calculation, how the velocity changes from time t equals 0 to t equals 20 seconds. Okay, so you just step by step, loads of detail, just right quickly. Okay, so we've got at t equals 0, the graph is flat, and so the velocity is 0. Then up to 4 seconds, the gradient increases, so the velocity is increasing in the positive direction. So the velocity, the speed forwards is increasing. Then from 4 seconds to 9 seconds, sort of roughly, it's about straight. And so the velocity is about constant for that time in the forwards direction. Then from 9 seconds to 12 seconds, the gradient decreases again back to 0. So that's the velocity getting smaller. The object's still moving forwards, but it's slowing down. Its velocity is getting smaller again. At 12 seconds, it is, for an instant, stationary, its velocity is 0 because the line is flat. From 12 seconds to 14 seconds, the gradient is increasing again, but it's now negative. So the object's velocity is increasing, but backwards. And then sort of, I'm not sure about this bit, but from 14 to 17 seconds, I think it's sort of straight again. And so that's constant velocity again, but again, the gradient's negative. So this is backwards, it's moving backwards. And then the gradient reduces back to 0 at 20 seconds. So that is the velocity reducing back to 0. In other words, at 20 seconds, the object has stopped again. You don't need all of that for the 5 marks, but if you had sort of any 5 points from that, you've got 4 marks, assuming that you have said how the speed changes, and also you've said how you know. So you've said how the gradient's changing.